In this video, I am going to work through the problems from the Chapter 2 practice test. This practice test was taken from a page in the free online college algebra textbook from openstacks.org. I've put the website up at the top. You can go there and access the entire book for free. So we're going to be walking through these problems for practice. So I suggest you try to do all of these problems on your own and then use this as a resource to make sure you worked through it correctly, your work is correct, and you got the right answer. If you don't know how to do one, then you can watch and see how I do it. But hopefully at this point you know how to work most of these on your own. Alright, so let's start with number 1. Graph the following. 2y equals 3x plus 4. So you should know that this is a linear equation. Since we have an x and a y, neither of them are raised to any exponents. They're not in the denominator or under a square root or something like that. They are both just raised to the first power. This is a linear equation. So what we want to do is get the y by itself. And there are multiple ways to graph this, but this is how I graph. I like to get the y by itself and get it in y equals mx plus b form or slope-intercept form. So we get y equals 3/2 x plus 2. So now you have it in this form. You know that the number in front of the x is the slope, and the number by itself, the constant, is the y value of the y-intercept. So the y-intercept is 0, 2. Okay, and now that you know that, you can graph the line. So draw a quick grid here. Remember, when you're graphing a line, you always start with a point. In this case, we have the y-intercept, that's our point. So we're going to start by graphing that, 0, 2. And then you use your slope. Remember, slope is rise over run. So you're going to rise the top amount or fall if it's negative and run. So we're going to start at our point of 0, 2, and then we're going to go up 3. And right 2. Remember that 2 negatives make a positive, so you could also go down 3 and left 2. Notice that that would still be on the line. And so, of course, since my graph is drawn by hand, it's going to be a little shaky, but it should be a perfectly straight line. And that would be a sketch of the graph. So that's number 1. Okay, let's go to number 2. Number 2, find the x and y intercepts for the following. So we have this equation, 2x minus 5y is equal to 6. Remember, when you're finding the intercepts, you want to let the other variable be 0. So if you're finding the x-intercepts, we're going to let y equal 0. So 2x minus 5 times 0 equals 6. That's just going to be 0. So we have 2x equals 6, which means x equals 3. So we have 3, 0 as the x-intercept. And now we want to find the y-intercept. So we're going to let x be 0. So we'll have 2 times 0 minus 5y equals 6. So that's 0. So we have negative 5y equals 6. Divide by negative 5. We get y equals negative 6/5. So we have 0, negative 6/5 as our y-intercept. All right, so those will be our intercepts. Number 3, find the x and y-intercepts of this equation, and sketch the graph of the line using just the intercepts plotted. Okay, so this is similar to number 2 and 1 kind of combined. So we have 3x minus 4y equals 12. They didn't have a graph number 2 because we had that negative 6/5, I believe it was, and that's going to be difficult to graph, so they gave us this one. So now what we want to do is find the x and y-intercepts. So the x-intercept we'll find if we let y be 0. So we'll have 3x minus 4 times 0 equals 12. So we have 3x equals 12. And so x is 4. So we have 4, 0 as our x-intercept. Now we're going to find the y-intercept. Let x be 0. So we're going to have 3 times 0 minus 4y is equal to 12. Divide by negative 4. So y is negative 3. So we have 0, negative 3 as our y-intercept. Now we just need to plot those 2 points, and then we can connect. Wow, that was bad. Then we can connect them to make a line. 1, 2, 3, 4. So we have the points. Oops, let's see. 4, 0. We have the points 0, negative 3. And you only need 2 points if you know it's a line to graph the line. And so there's our line. All right, number 4. Find the exact distance between 5, negative 3 and negative 2, 8. Find the coordinates of the midpoint of the line segment joining the 2 points. So the distance is going to be given by the formula x2 minus x1. So 5 minus a negative 2. The minus a negative, remember, if you have 5 minus a negative 2, these 2 negatives end up making a plus. So I went ahead and wrote it like that in the formula. Squared plus y2 minus y1, or, a y minus a y. It's 8 minus a negative 3 squared. Okay? So now we want to find that. So 5 plus 2 is 7. 8 plus 3 is 11. We have 49 plus 121. So 170. Remember, once you find the 170, you need to make sure that you can't reduce it. So this would be 17 times 10. 17 is prime. 10 can break down into 5 and 2. 5 and 2 are prime. There are no pairs, so you can't reduce this radical. So this is the exact distance between the 2 points. Square root of 170. The exact is important here. That's letting you know that you should not put a decimal approximation in. If it says find the exact distance, you have to leave it in radical form, unless it's a perfect square. So for example, if it was the square root of 81, you would just say 9. But in this case, you have to leave it as a radical. Do not put a decimal, it will be wrong. And then find the coordinates of the midpoint. So the midpoint is found by using the formula x1 plus x2 divided by 2. You're basically just averaging the 2 points and finding the middle. And then y1 plus y2 over 2. So we have, let's see, 5 plus a negative 2 over 2. And then we have negative 3 plus 8 over 2. And so now we're going to just simplify that. So 5 plus negative 2 is 3. So 3 halves. And negative 3 plus 8 is 5. So 5 halves. So that is the midpoint. Remember that for your midterm, you need to have these formulas memorized. So you need to memorize the distance formula, and you need to memorize the midpoint formula. All right, number 5. Write the interval notation for the set of numbers represented by this set x such that x is less than or equal to 9. So if x is less than or equal to 9, if you're not sure what that looks like in interval notation, I recommend that you graph this on a number line. So if you're going to graph it on a number line, you're going to put your boundary point on the number line. X is less than or equal to 9. The numbers that are less than 9 are this way. And then since it has an or equal to, you're going to use a square bracket. So from there, you can see your interval notation. Your interval notation is left to right. The leftmost value, since it goes forever to the left, is negative infinity. The rightmost value is 9. Infinity and negative infinity always get a parentheses. 9 gets a square bracket. So there is your interval notation for number 5. Since we have more space, let's just go ahead and do number 7. So number 7, solve for x. So we're just going to solve this equation. So 3 times 2x minus 5 minus 3 times x minus 7 is equal to 2x minus 9. Okay, so let's distribute the 3 and the negative 3. So we're going to distribute here and this negative 3 here. And from that, we're going to get 6x minus 15 minus 3x plus 21 is equal to 2x minus 9. And now we want to combine our like terms. So we have 6x and negative 3x. Those will combine. And we have negative 15 and positive 21. So those will combine. So 6x minus 3x is 3x. Negative 15 plus 21 is plus 6. Bring down the stuff on the other side. Now we want to combine everything on the same side, so we need to move the x values. So minus 2x from both sides. That'll give us the x on the left. And we need to do the minus 6 on both sides to get the constants on the right. So from that, we will see that the 6 and negative 6 cancel on the left. 2x and negative 2x cancel on the right. 3x minus 2x is x equals negative 9 minus 6 is negative 15. So x is negative 15. So that's our solution. And I know in Infinity it's kind of finicky on how you put your answer in, but you could put it in like that if that's the way it asks for it. If it asks for it in solution, a solution set, you can write it like that. Okay. All right, let's see, number 9. We might not have space for number 9 here. Let me go ahead and erase this, and we'll go ahead and do number 9, and then we'll skip over and do some of the evens. All right, number 9. Solve for x. So we have 5 over x plus 4 equals 4 plus 3 over x minus 2. All right, so this is a rational equation. We've got these fractions with variables involved. The first thing we want to do is make sure you realize everything is going to be kind of treated like a fraction. So if you have a whole number, you can put it over 1 to make it a fraction as well. And then what you want to do is look at all of your denominators and find the least common denominator. So we have a factor of x plus 4. We have a factor of x minus 2. So our LCD is going to be the product of each unique factor of all the denominators. So one unique factor is x plus 4. The next unique factor is 1. Well, I don't need to multiply by 1. And then the next unique factor is x minus 2. So my LCD is going to be x plus 4x minus 2. What you're going to do is you're going to multiply each side by that and then distribute. So you'll have x plus 4 times x minus 2. And when you distribute, you end up multiplying it by every fraction. Okay, so now you're going to be able to cancel out your common factors. So x plus 4 is common here. And from that fraction, you are left with a 5 and the x minus 2. So you're going to have 5 times x minus 2 left from that one. From the second fraction, you have a 1, so that's not going to cancel with anything. So you're going to end up with 4 times x plus 4 times x minus 2. And then from the third fraction, the x minus 2's cancel out. And so from that fraction, you're going to be left with a plus 3 times x plus 4. So now we want to distribute everything and solve for x. So this is going to be, we're going to distribute there, here, and then remember for this middle one, we're going to have to FOIL it or use repeated distribution. And then we'll have to distribute that 4. So we're going to have 5x minus 10 is equal to 4 times, I'm going to do the FOIL first. You'll have x squared minus 2x plus 4x minus 8 plus 3x plus 12. Now I can combine these two. So I'm going to have 4 times x squared plus 2x minus 8. Then I have to distribute that 4 to all 3 terms in the parentheses. So I'm going to have 5x minus 10 is equal to 4x squared plus 8x minus 32. So I'm bringing all this down, and then I've got to bring this down. So plus 3x plus 12. Okay, so now that I've got it all FOILed out, my son is so excited he's about to eat oatmeal, if you can hear a kid screaming in the background. So now we are going to add our like terms. So 8x and 3x are like, negative 32 and 12 are like. So we're going to have 5x minus 10 is equal to 4x squared plus 11x minus 20. All right. And now we're going to see, well, what kind of equation do we have? So since we have the 4x squared, that's a quadratic equation. So to solve a quadratic equation, we have to get all of our pieces or terms on the same side and set it equal to 0. So that's what I'm going to do here. So I'm going to subtract 5x from both sides. And I'm going to add 10 to both sides. So I'm moving everything to the right, and that's because my x squared term is already positive on that side. So this will cancel, this will cancel. I will have 4x squared plus 6x minus 10 is equal to 0. So now I have my quadratic equation set equal to 0. So at this point I can either factor or I can do the quadratic formula. So let's try to factor. So if I factor this, first of all, I have a common factor of a 2. So I can factor that out if I want. So 2x squared plus 3x minus 5 equals 0. And really I can divide everything by 2. That's probably easier than keeping the 2 here. So if I divide everything by 2, let's go back and do that. So when you have a common factor and you have an equation, you can divide both sides of the equation by 2. If you're just factoring an expression, you have to keep the 2 out front. But if you have an equation, you can divide everything by 2. That'll give us 2x squared plus 3x minus 5 is equal to 0. Okay, and so now I can try to factor that. So to factor, when you have a number in front of x squared other than a 1, you're going to find the product of a and c. So you need your product to be negative 10 and your sum to be 3. So if we use 5 and negative 2, that will multiply to give negative 10 and add to give positive 3. So those numbers will work. So I'm going to bring down the 2x squared. I'm going to split the x piece apart into those two factors. So plus 5x minus 2x, bring down the negative 5, is equal to 0. Now I'm going to do factor by grouping. So what's in common with the first two is an x. Now I know some of you are going to be looking at this and it's going to drive you crazy that the 2 wasn't first, so the 2's could match up, and the 5's was second, so the 5's could match up. And that's fine. If you wrote this equation with the negative 2x before the 5x and you group different, that's fine. You're going to end up with the same answer in the end. So the way I grouped it, x is the only thing in common in the first pair. So then we'll have 2x plus 5 left over. We have to factor out a negative. There's nothing else in common, so it's going to end up being 2x plus 5. Remember, because we're dividing by a negative. Now we have 2x plus 5 as our common factor, and x minus 1 is left over. The x minus 1 is here and here, right? This is understood to be a 1 equals 0. And now we can set each factor equal to 0 separately and solve. So we're going to have 2x plus 5 equals 0, and x minus 1 equals 0. So that's going to be 2x equals negative 5. So x is negative 5 halves. So that's one solution. And the other one will be a 1. So x equals 1. So the two solutions are negative 5 halves and 1. Oops. Okay, so that is number 9. Okay, so on the even side, we've done 2 and 4, so now we're going to do number 6. So number 6, solve for x. So we've got 5x plus 8 is equal to 3x minus 10. So this one, we're going to subtract 3x from both sides because we have a linear equation. We want the x's on one side and the constants on the other. Subtract 8 from both sides. So that moves the x's to the left and the constants to the right. 5x minus 3x is 2x. Negative 10 minus 8 is negative 18. We're going to divide by 2. So then x will be negative 9. Okay, number 8, we have solve for x. So we have x over 2 plus 1 is equal to 4 over x. So 1 we can treat as a fraction. Remember, we can put that over 1. To find our LCD, we want to use each unique factor in all of the denominators and multiply them together. So we have a 2, a 1, and an x. So if we multiply all that together, we get 2x. So now I'm going to multiply each fraction by the LCD. Cancel out common factors. So in the first fraction, the 2's cancel out, and I'm left with x times x, which is x squared. In the second fraction, nothing cancels out. You just are left with a 2x. And in the third fraction, the x's cancel out, and we're going to be left with 4 times 2, which is 8. So we have a quadratic equation. To solve that, I want to move everything to the same side and set it equal to 0. So I'm going to have x squared plus 2x minus 8 equals 0. I can factor this. So x plus 4, x minus 2. If I multiply 4 and negative 2, I get negative 8. And if I add 4 and negative 2, I get positive 2. So that will work. Now set each factor equal to 0 and solve. So x is negative 4. Or x is 2. So two solutions for quadratic. We have negative 4 and 2. Okay, so I'm going to erase all of this work and then we're going to do number 10. The perimeter of a triangle is 30 inches. So we're dealing with a triangle. Remember, a perimeter is when you just add up all the sides. The longest side is 2 less than 3 times the shortest side. Okay, so it's comparing to the shortest side. It is the longest leg compared to the shortest side. So the shortest side is going to be x, okay, just our plain variable. Now we're going to write the longest side using that information. So the longest side is 2 less than 3 times the shortest side. Less than flips the order, so it's going to be 3 times the shortest side first, then less 2. So 2 less than 3 times the shortest side. And the other side is 2 more than twice the shortest side. Okay, so the other side is 2 more than twice the shortest side. So it's referencing the shortest side again. 2 more than twice the shortest side. So twice the shortest side plus 2 more. So that's how I represent each of the sides. Now it says find the length of each side. So the perimeter is adding up all the sides. They say the perimeter is 30 inches. So I'm just going to add all these up and set it equal to 30. So 2x plus 2 plus 3x minus 2 plus x is equal to 30. The parentheses are not really necessary because I'm adding everything. I did that though so you can see where all the pieces are coming from, right? Each side is in parentheses, so you can see the 3 sides. So without the parentheses, you just have 2x plus 2 plus 3x minus 2 plus x equals 30. And then what you're going to do is you're going to combine all of your like terms. So we've got 2x, we've got plus 3x, we've got plus x. Those are all like. We have 2 and minus 2. So notice those are going to cancel out. Those are opposites. So 2x and 3x is 5x plus 1 more is 6x equals 30. Divide by 6. So I get x equals 5. Okay, now what is x? Here's where students get into trouble a lot of times, is they didn't draw a diagram to begin with, or they didn't label anything, and so they have no clue what the 5 represents. So notice the x is red. I highlighted red in the word sentence, the shortest side. So x represents the shortest side. So I can say the shortest side is 5 inches. Okay, so 5. And what I need to do here is just plug in my 5. So this is 5. To find the longest side, which is in blue, I just plug 5 in for x. So that's going to be 15 minus 2, which is 13. So we can say the longest side is 13 inches. Okay. And then the green is the other side, is what they call it. So 2 times 5 plus 2, which would be 10 plus 2, which is 12. So the other side is 12 inches. All right. So on a test, they're probably going to want you to label it so they know that you know which side is which length. So that would be the best way to go about that. I highly encourage you to draw a diagram or label or do both. You need to do something to let yourself know what is represented by your variable and what's represented by your other expressions. Number 11, we have solve for x, write the answer in simplest radical form. So x squared over 3 minus x is equal to negative 1/2. So here the first thing we want to do is write the x as a fraction, so I can write that as being over 1. Next we want to find the LCD. Notice the LCD, the denominators this time are just numbers. So we have a 3, a 1, and a 2. So if we multiply all those together, we get 6. So we're going to multiply each fraction by 6 and reduce. So for the first one, 3 and 6 are both divisible by 3. So the 3 will become a 1, the 6 becomes a 2. So from that fraction, we're left with 2 times x squared, which is 2x squared. From the second fraction, nothing cancels out, so we have minus 6x. And on the other side, the third fraction, the 2 will reduce with a 6. So 2 divided by 2 is 1, 6 divided by 2 is 3. So then we have a negative 1 times 3, so we get negative 3. So we can see that again we get a quadratic equation. So we're going to have 2x squared minus 6x plus 3 equals 0. So remember what you're doing is you're adding the 3 to both sides to get it set equal to 0. And now we want to try to factor. It doesn't look like this will factor, so we're going to end up having to use another process. So let's do the quadratic formula. So you need to make sure you have the quadratic formula memorized. So that will be x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So now we just need to remember a, b, and c. So remember that a is in front of your x squared, b is in front of x, and c is the constant when it's set equal to 0. So now we're going to plug stuff in. So x will be the opposite of b. b is negative 6, so the opposite of that is positive 6. Plus or minus the square root of b squared, so that's negative 6 squared, minus 4 times a, which is 2, times c, which is 3, all over 2 times a, which is 2. And once you have your variables, your a, b, and c identified, you just plug them in and then simplify what you have. So you have 6 plus or minus the square root of negative 6 squared is positive 36. You have one negative, so it'll be a minus. 8 times 3 is 24 over 4. Finish what's under the radical, so 6 plus or minus the square root. 36 minus 24 is 12 over 4. Now, do not make the mistake of trying to reduce here. You cannot reduce the 6 and the 4. You cannot do that at this point because you have the 6 attached to the radical. You have to be able to factor something out or reduce it out of all the pieces. So what you have to do here is try to reduce the radical and then see if you can reduce your fraction from there. So I can reduce my radical. So if I try to reduce the 12, 12 breaks down into 4 times 3. 4 is 2 times 2. Now you can see that you have a pair of 2's and 1 3 left over. So the 2 comes out of the radical and the 3 stays under. So now we're going to have 6 plus or minus 2 square root of 3 over 4. Now what you're looking for is, do you have a common factor in all of the terms or all of the pieces so that you can divide it out of everything? So you're looking at the 6, the 2, and the 4. So you have two terms on the top, and you have the denominator that all have a 2 in common. So you're going to divide 2 out of all of those pieces. So 4 divided by 2 is 2, 6 divided by 2 is 3, and 2 divided by 2 is a 1. So you can only reduce if you have a common factor on all of the terms. In the previous spot, we had the 6 and the 4, but we did not have a number to reduce with the radical, so that's why we couldn't reduce at that point. So now we're going to rewrite this. So we have 3 plus or minus, the 1 is understood to be in front of the radical, so we don't write it, over 2. And that is as good as it gets. That's as much as we can do to simplify that. Okay, number 12. We have 3x minus 8 is less than or equal to 4, so we want to solve. So we're going to add 8 to both sides. We get 3x is less than or equal to 12. Divide by 3. So we get x is less than or equal to 4. So that's solved. Doesn't tell us to do anything else, but you should know how to graph that on a number line, and you should also know how to write it in interval notation. So I'm going to do both of those things as well. So on the number line, you put your boundary point. Since this says it's less than or equal to 4, the numbers less than 4 are to the left. And then since it has a equal to sign under it, you're going to have a bracket. And so then that's the graph, and then the interval notation, remember it's left to right. The smallest or the leftmost value, it goes forever to the left, is negative infinity, that gets a parentheses. The rightmost value is 4, that gets a bracket. All right, number 13. So for 13, we have the absolute value of 2x plus 3 is less than 5. So for the absolute value, remember the first thing you want to do is make sure the absolute value is by itself on one side of the inequality symbol. It is. And then you want to make sure you're comparing to a positive. You are, because remember if you compare to a negative, that's one of the special cases. And then once you verify both of those things, you want to look and see what inequality symbol you have. So here we have a less than. So remember that means that the distance has to be within 5 units of the absolute value. So that means it could be 5 units to the right or 5 units to the left. So that's when you kind of trap it between the 5s. So you have negative 5 is less than 2x plus 3, whoops, no absolute value, is less than 5. So you're going to trap it between the 5s. And then you're going to solve. So we've got to get the x by itself. So subtract 3 from all 3 pieces. So we have negative 8 is less than 2x is less than 2. Now you want to divide everything by 2. So you'll have negative 4 is less than x is less than 1. So x is trapped between negative 4 and 1. So again, it just says solve, so you would be done. But if they want you to represent your solution set, you know, in interval notation or something, you need to know how to do that. So we have negative 4 and 1 are our 2 boundary points. X is trapped between that, so that'll be from here to here. Since you do not have an or equal to sign under it, you're going to have parentheses. And so we have negative 4 is the lower value with parentheses, 1 is the greater value with parentheses. So that would be our interval notation. That would be how we would represent that in interval notation. Number 14, we have the absolute value of 3x minus 2 is greater than or equal to 4. We have the absolute value by itself. We're comparing to a positive. Here we have a greater than symbol. So this is a greater than. So for greater than, you have to split it into 2 equations or 2 inequalities and solve them both. So your first inequality is 3x minus 2. You flip the sign, change the sign. So less than or equal to negative 4. Or you have 3x minus 2 is greater than or equal to 4. The second one you just leave as is, just drop the absolute value symbols. And now you're going to solve each of those. So we're going to add 2 to both sides. So we get 3x is less than or equal to negative 2. Divide by 3, sorry. So x is less than or equal to negative 2/3. So that's one part. Now we're going to solve the other one. So add 2 to both sides. So we have 3x is greater than or equal to 6. Divide by 3. So x is greater than or equal to 2. Remember, if you divide or multiply by a negative, you have to flip the inequality symbol. We haven't seen that yet, but keep that in mind. So we have our two solutions, so we're going to graph them on the same number line. So we have negative 2/3 is one boundary point and 2 is the other. So we want to see when x is less than or equal to negative 2/3, so that would be to the left. And since it has an or equal to, it's a bracket. And then we have x is greater than or equal to 2, so that would be to the right. Since it has an or equal to, that would get a bracket. And so our interval notation, since our graph is in two distinct pieces, we have to write two distinct pieces for our interval notation. So the first one will be negative infinity to negative 2/3. Union, the second one will be 2 to infinity. 15, we want to find the equation of the line that passes through the points negative 4, 2 and 5, negative 3. So the first thing we want to do is find the slope. So remember that that's y2 minus y1 over x2 minus x1. So something else you need to have memorized. So that's going to be negative 3 minus 2 over 5 minus a negative 4. So that's going to be negative 5 over 9. So our slope will be negative 5 over 9. Now we need to find the equation. So remember, when you're finding an equation, you have to have a slope. That's why I started by finding the slope. And now we're going to use the slope and one of the points. It doesn't matter which point, so I'm just going to choose this one, but you could use either point you want to find the equation of the line. So when you have a slope and a random point, you need to use the point slope form of the line. So that's y minus y1 equals m times x minus x1, another thing you need to have memorized. And so now you're going to plug stuff in for the y1, the m, and the x1. So it'll be y minus, the y value is 2, is equal to m, negative 5/9, times x minus the x value, which is negative 4. So minus a negative 4 will be plus 4. And now it doesn't tell you what form you need to write it in. I'm just going to go ahead and write it in slope-intercept form. That means I need to distribute the negative 5/9. So I'll get y minus 2 is equal to negative 5/9 x minus 20 over 9. Now I want to get the y by itself. So add 2 to both sides. So if you're adding fractions, you need to have a common denominator. So rather than 2, I'm going to use, that's like 2 over 1. To find a common denominator, you want to multiply by 9 over 9. So that'll be 18 over 9. So we're going to end up with plus 18 over 9. So we'll have y equals negative 5/9 x. Negative 20 over 9 plus 18 over 9 is negative 2 over 9. And so that would be our linear equation in slope-intercept form. Number 16, find the equation of the line that has an undefined slope and passes through the point 4, 3. Undefined slope goes with a vertical line. So an undefined slope goes with a vertical line. A vertical line has the equation x equals a number. Since our point is 4, 3, x is going to be the x value, which is 4. So x equals 4 is the equation for that line. Number 17, we want to find the equation of a line that passes through the point 2, 1 and is perpendicular to y equals negative 2/5 x plus 3. So first thing is we need to find a slope. So that's the first thing you should make sure you have when you're doing an equation of a line is a slope. To find the slope, we have perpendicular to this equation. So remember, lines that are perpendicular have opposite reciprocal slopes. So if this line has the slope of negative 2/5, our line is going to have a positive 5/2 as our slope. So that's the first thing, is to find the slope. And then we're going to use the slope and this point and use the point slope form again. So y minus y1 is equal to m times x minus x1. So y minus 1 is equal to m times x minus 2. And again, I'm going to put it in slope-intercept form. So distribute the 5/2. So y minus 1 is equal to 5/2 x minus, that'll be 10 over 2, which is 5. So 5/2 times negative 2 is negative 10 over 2, which is negative 5, okay? And then I want to get the y by itself, so add 1 to both sides. So y equals 5/2 x minus 4. So that's the equation of the line in slope-intercept form. Number 18, we're going to add the complex numbers. So the parentheses are not really necessary because it's a plus. So we have 3 minus 2i plus 4 minus I. We're just going to combine our like terms. So we're going to add our real parts, which are the parts without the I. We're going to add the imaginary parts, which are the parts with the i's. And then write it in complex form, which is a plus bi. So 3 plus 4 is 7. Negative 2i minus I is negative 3i. And that is the sum. Number 19, we are asked to simplify this. So we have the square root of a negative 4 plus 3 times the square root of negative 16. So we want to simplify the radicals. So remember that the negative under the radical comes out as an I. So the square root of 4 is 2. So the square root of negative 4 will be 2i. So the 2 comes from the 4 and the I comes from the negative. Since those both come out of the radical, we do not have the radical or the square root symbol anymore. Then we have plus 3 times the square root of negative 16 is going to be 4i. So that'll be 2i plus 12i. And so those are like terms. We can add those together. We will get 14i. Number 20, we want to multiply these. So we have 5i times 5 minus 3i. So we're going to distribute the 5i to both terms. So we're going to have 25i minus 15i squared. Remember here that you cannot have an I to a power. That's not considered simplified. So I squared is equal to negative 1. So we're going to have 25i. Negative 15 times a negative 1 is positive 15. And then remember, you have to make sure you write it in the correct form, a plus bi. So the real part has to go first, and the imaginary part has to go second. So 15 plus 25i would be our complex number here. Number 21, we're asked to divide. So 4 minus I over 2 plus 3i. Now this one is sometimes confusing to students because you hear divide and so you're trying to do some kind of division process, but what you're going to actually do is you're trying to get the I out of the denominator. So remember I is equal to the square root of a -1. And we talked about before rationalizing the denominator, so we don't want square roots in the bottom, which means we don't want i's on the denominator or the bottom. So what you're going to do is if you have a complex number with a real and imaginary part, you're going to get rid of that by multiplying by the complex conjugate, which is the same two terms but a different middle sign. That will always get rid of your i's. So we had 2 plus 3i, we're going to multiply by 2 minus 3i. Remember, when you're dealing with fractions, you have to do the same thing to the top and the bottom in order to keep it balanced or equivalent. And so we can put these in parentheses so that we know that we need to distribute or FOIL. So if we distribute everything fully on the top, we will get 4 times 2, which is 8, 4 times -3i, which is -12i. Negative I times 2 is -2i. Negative I times -3i is plus 3i squared. Now on the bottom, we're going to have 2 times 2 is 4. 2 times -3i is -6i. 3i times 2 is positive 6i. And 3i times -3i is -9i squared. Now, if you're used to using these complex conjugates, you should know that in the denominator, the I terms will always be opposites and they'll cancel out. So you only have to really multiply the like terms, so like 2 times 2 and 3i times -3i. But if you don't want to memorize that or you don't remember that, it's fine. Just multiply like normal and cancel those out. And so now we're going to combine like terms. So in the numerator, I have an 8. I have like terms of -12i and -2i. So those are going to combine to give me -14i. And also in the numerator, I have this I squared. Remember, that is a -1. So we're going to have 3 times -1 is -3. And then in the denominator, we have another I squared. That's going to be a -1. So we have 4 minus 9 times a -1 is plus 9. So we're going to end up with, here we have other like terms, 8 minus 3. So we're going to have 8 minus 3, which is 5, minus 14i all over 13. And now your last step is to separate your real and imaginary parts. So you'll have 5 over 13 minus 14 over 13i. That is complete for number 21. Number 22, so we're going to solve x squared minus 4x plus 7 equals 0. So this one cannot factor, so we're going to solve by the quadratic formula. So -b plus or minus the square root of b squared minus 4ac all over 2a. Again, make sure you have that memorized. So the opposite of b is -4, so the opposite of that would be +4, plus or minus the square root of b squared, so -4 squared, minus 4 times a, which is 1, c, which is 7, all over 2a, which is 1. So we're going to have 4 plus or minus the square root of -4 squared is positive 16, minus 4 times 1 times 7 is 28, all over 2. So we have 4 plus or minus the square root of, it looks like a -12, all over 2. So we need to reduce that 12. We reduced it earlier. We found it was 2 square root of 3. So we have 4 plus or minus 2i square root of 3 over 2. So we did the work for that in an earlier problem. In case you didn't watch that one, I guess I should do that one real quick. So 2 comes out, 3 stays under. And the negative comes out as the I. And so now everything is evenly divisible by 2. So this will be 2 plus or minus I square root of 3. And that would be your two solutions. Usually it's fine if you have the I before the square root to clarify that that's not under the radical. So you should be able to leave it like that. Number 23. So solve. So we have 3x minus 1 squared minus 1 equals 24. So we need to FOIL that 3x minus 1 all the way out. So remember that looks like this. So when we distribute it all the way out, we get 9x squared minus 3x plus 1. That's all from the parentheses. Then we have to bring down the negative 1 and the equals 24. So notice the 1 and the negative 1 cancel out. So we'll have 9x squared minus 6x equals 24. Now we want to move the 24 over by subtracting it. So we have 9x squared minus 6x minus 24 equals 0. We subtracted the 24 from both sides. All right, so now in order to make my numbers a little smaller, I could divide everything by 3. But if you didn't see that, that's okay. You can do the quadratic formula with what you have. So I'm going to get 3x squared minus 2x minus 8 is equal to 0. Let's see. I'm going to try to factor. I think we're going to be able to factor it. Oh, I just realized we could have done this with the square root property. But that's okay. We'll keep going now. We've already done it this far. So let's see, if I'm going to try to factor, I'm going to have the product is negative 24 and the sum is negative 2. So if I use negative 6 and positive 4, that multiplies to get negative 24 and adds to get negative 2. So I'm going to have 3x squared. I break this apart with my two factors I found over here. So minus 6x plus 4x, bring down the minus 8 equals 0. Now we're going to factor by grouping. So 3x is in common, so we get x minus 2. Bring down the plus. 4 is in common, we get x minus 2. Remember, when you're doing factor by grouping, you should get the same thing in parentheses. So then we have x minus 2, which is in common, and then the leftovers is 3 plus 4 equals 0. And now we can set each factor equal to 0 and solve. So when we do that, we get x equals 2 because we add 2 to both sides, right? And subtract 4, divide by 3. So we get x equals negative 4/3. So our two solutions are 2 and negative 4/3. Okay, so we got our answers and we don't have to do anything else. But what I want to do is try it using a different approach to show you what I could have done. So for number 23, we have 3x minus 1 squared minus 1 equals 24. Notice I have a quantity squared. So what I could do is add 1 to both sides so that I get 3x minus 1 all squared is equal to 25. And then at that point we had the square root property, so we could take the square root of both sides, plus or minus. So it would be 3x minus 1, the square root undoes the square, is equal to plus or minus 5. And then it's just a matter of solving for x. So add 1 to both sides. So we have 3x equals, do not say plus or minus 4. That is not correct. It's a positive 5 plus 1, or it's a negative 5 plus 1. So you're going to have two possibilities. So you can write this as 1 plus or minus 5 for now. Divide by 3. So x is, okay, if you do 1 plus 5, you get 6. So here's our two choices. 1 plus 5 over 3 is 6 over 3, which is 2. So 2. 1 minus 5 over 3 is negative 4 over 3, which is negative 4/3. So those are the same answers we got before, but it's actually a lot shorter this way. So anyway, multiple ways to solve quadratic equations. Pick your poison. Number 24, I have solve for x squared minus 6x equals 13. So here again I have a quadratic equation. I'm going to move the 13 over by subtracting it from both sides. So now I'm going to use the quadratic formula. So x equals the opposite of b. So b is negative 6. The opposite of that would be positive 6. Plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So we have 6 plus or minus the square root of 36. Now we have two negatives. So this is going to be a plus 52 all over 2. So 6 plus or minus the square root of 88 over 2. Okay, so now we need to reduce the radical. So that's 44 times 2. That's 11 times 4. That's 4, oops, not 4. 2 times 2. All right, so we have a pair of 2's. We have a leftover 11 and a leftover 2. So that's going to be 6 plus or minus. The pair of 2's comes out as 2. The leftover 11 and the leftover 2 multiply back together. Now we can divide by 2. So we have 3 plus or minus the square root of 22. Number 25. We have 4x squared minus 4x minus 1 equals 0. So again, I'm going to need to do the quadratic formula. So x equals the opposite of b. So b is negative 4, so it'll be a positive 4 plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Reducing, I get 4 plus or minus the square root of 16. This will be a plus 16 over 8. 16 and 16 is 32. 32 will reduce, so we're going to have 16 times 2, 4 times 4. So I can use the pair right there in the leftover 2. So that's going to be 4 plus or minus 4 square root of 2 over 8. Now I have a common factor in all three terms, so 4, 4, and 8. Those are all divisible by 4. So 4 divided by 4 is 1, 4 divided by 4 is 1, 8 divided by 4 is 2. So that's going to give us 1 plus or minus the square root of 2 over 2. Number 26. We have the square root of x minus 7 is equal to x minus 7. So here we want to get rid of the radical. So we're going to square both sides. So we're going to have x minus 7 is equal to x minus 7 squared, which is x minus 7 times x minus 7. We're going to distribute that all the way out. So that'll be x squared minus 7x plus 49. Combine like terms, so x minus 7 is equal to x squared minus 14x plus 49. All right, so now we're going to subtract x from both sides and add 7 to both sides. Again, we have a quadratic equation, so we're trying to get it set equal to 0. So that cancels, that cancels. We have x squared minus 15x plus 56 equals 0. Okay, so at this point, I've been working these problems for over an hour. You should take a break. So if I start making mistakes, please let me know in the comments that I, made a mistake on a certain number, and I will check it out and revise if necessary, or, let everyone know that there's a mistake. So we have this quadratic equation. So we're going to try to, I think we can factor it, so let's try to do that. So we need it to multiply to get 56 and add to get 15. So we should be able to use 8 and 7, both negatives. So 8 times 7, negative 8 times negative 7 is positive 56. And then negative 8 plus negative 7 is negative 15, so that should work. Excuse me. So now we have x minus 8 equals 0, or x minus 7 equals 0. So now we want to solve. So add 8 to both sides. We get x is equal to 8. Add 7 to both sides. We get x is equal to 7. So now it's very tempting to say, oh, our two answers are 8 and 7. But if you remember, you have to check your work for the radical equations. So for 26, we started with the radical. We need to check those answers to make sure they actually are answers. So we're going to check. So first I'm going to check 8. So check x equals 8. So we're going to plug it in the original. So we have x minus 7. So 8 minus 7 is equal to 8 minus 7. The square root of 8 minus 7 equals 8 minus 7. So that's the square root of 1. The square root of 1 is 1. 8 minus 7 is 1. That checks. So this is a solution. Now we want to check the other one. So check x equals 7. So we have the square root of 7 minus 7 is equal to 7 minus 7. So 7 minus 7 is 0. The square root of 0 is 0. This one checks as well. So both of these are valid solutions for the equation. So both of those are valid solutions. Number 27. So 27, we have 2 plus the square root of 12 minus 2x is equal to x. So we want to get the square root by itself. So first we're going to start out by subtracting 2 from both sides. So we have the square root of 12 minus 2x is equal to x minus 2. Now that we have the square root by itself, or the square root isolated, we're going to square both sides of the equation to get rid of the square root. So that'll leave 12 minus 2x on the left, and on the right we have x minus 2, which squared, which is this. So we have 12 minus 2x is equal to x squared minus 2x plus 4. We have a quadratic equation, so we need to get everything on the same side set equal to 0. I'm going to start by combining my like terms over here. So 12 minus 2x is equal to x squared minus 4x plus 4. Now I'm going to add 2x to both sides and subtract 12 from both sides. So I get x squared minus 2x minus 8 equals 0. So now I need to solve this quadratic equation. I can do that by factoring or quadratic formula. I'm going to factor. So x minus 4x plus 2. So negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2, so that works. So I have x minus 4 equals 0. So if I add 4 to both sides, I will get x equals 4. And then I have x plus 2 equals 0. So if I subtract 2 from both sides, I will get x equals negative 2. Again, I started with a radical in my equation, so I have to check these. Do not forget this step. So if I'm going to check, first I need to check x equals 4. So everywhere I see an x, I'm going to put a 4. So 2 plus the square root of 12 minus 2 times 4 is equal to 4. So that's going to be 2 plus the square root of 12 minus 8 is equal to 4. So 2 plus the square root of 4 is equal to 4. The square root of 4 is 2. So 2 plus 2 equals 4. That does check. So 4 is a valid solution. Okay, so now I want to check the next possible solution. So check x equals negative 2. So we're going to get 2 plus the square root of 12 minus 2 times a negative 2 is equal to a negative 2. So it's going to be 2 plus the square root of 12 plus 4, which is going to be 2 plus the square root of 16, which is 2 plus 4. And we want to know if that's equal to -2. Well, no, that's going to be 6 equals -2. That's not true. So that's not a valid solution. So our only solution is 4. And again, you would only know that if you're checking your answers. So make sure you check your answers for these. Number 28. Okay, so we're going to solve. So we have x minus 1 to the 2/3 power is equal to 9. So you want to rewrite this using radicals. So the top is the exponent and the bottom is the root. So what you want to do here is you want to know that this is the cube root of x minus 1 squared is equal to 9. So the first thing you want to do is get rid of the cube root. So to get rid of a cube root, you're going to cube both sides. So the cube will get rid of the cube root. So I'll have x minus 1 squared is equal to 9 cubed. 9 cubed is 729. Now the next thing you want to do is you want to get rid of the square. So you're going to take the square root of both sides. Don't forget to put plus or minus. So the square root undoes the square. So you get x minus 1 equals. The square root of 729 is 27. So that'll be plus or minus 27. And then the last step is to add 1 to both sides. So you get x equals 1 plus or minus 27. Well, 1 plus 27 is 28, so that's one solution. 1 minus 27 is -26, so that's your other solution. So -26 and 28 are your two solutions. Number 29. For the following exercises, find the real solutions of each equation by factoring. So for number 29, what you should notice is that you have 4 terms. So for 4-term polynomials, the only thing we really know how to do at this point is factor by grouping. So we're going to do that. So what's in common with the first pair is x squared. And if I divide out x squared, that leaves 2x minus 1. I'm going to bring down the negative. What's in common with the next pair is 4. So I'm dividing out a -4. So -8x divided by -4 is positive 2x. 4 divided by -4 is -1 is equal to 0. Notice I have the same thing in parentheses, which you should. So that's now your common factor. And the leftovers are x squared and -4. So that makes up your second factor. Okay, so now I have 2x minus 1 times x squared minus 4x. The x squared minus 4x is the difference of squares, so that can be factored again. So I'm going to bring down the 2x minus 1, and then the x squared minus 4 will factor into x plus 2, x minus 2, and it doesn't matter which way you put them in. It could be minus first. Now I have them all as linear factors, so each one has no exponents in it, and I can set each of those equal to 0 separately and solve and get my 3 solutions. So subtracting 1, I need to add 1 to both sides. So I have 2x equals 1, divide by 2, so x equals 1/2. That's one solution. Here I'm going to add 2 to both sides, so x equals 2. And here I'm going to subtract 2 from both sides, so x equals -2. So those are my 3 solutions, 1/2, 2, and -2. All right, number 30. So for number 30, this is a quadratic of type, and we talked about using a substitution, a U substitution. And so we know this is a quadratic of type because we have something squared minus 3 times something minus 4. So I'm calling it something. I have this squared, so that's acting as my variable. And then I have that here. So if I replaced it with an x, the red, it looks like x squared minus 3x minus 4. Well, that would be a quadratic equation. So in order to make it look like that, I'm going to use substitution. And remember in our video we talked about the middle thing being u. So we're going to let u equal x plus 5. Okay, so we're going to let u equal x plus 5. And then u squared then would be x plus 5 squared. And so I'm going to use that to rewrite my equation. So u squared is x plus 5 squared. Well, that's the first term, so that's going to be u squared. Minus 3 times x plus 5, which is u, minus 4 is equal to 0. So you can see everywhere I have a red box, I replaced that with a u. Okay? And so now I'm going to just use the quadratic formula or factoring on this equation. So this one looks like it will factor. So u, what multiplies to get negative 4 and adds to get negative 3? Well, let's try negative 4 and positive 1. So that will multiply to get negative 4 and add to get negative 3. So that works. So now I have u minus 4 equals 0, or u plus 1 equals 0. So add 4 to both sides here. So that's going to give me u equals 4. I want to subtract 1 from both sides here. So that's going to give me u equals negative 1. Okay, so now we've solved for u, but we need to solve for x. So what we want to do at this point is plug in this everywhere we see a u. So we're going to have x plus 5 equals 4 and x plus 5 equals negative 1 because that's what we had u equal. And then we're going to just solve that. So minus 5 from both sides. We end up with x equals negative 1. Minus 5 from both sides in this case. We end up with x equals negative 6. So our two solutions for x are negative 1 and negative 6. So remember, you're not done if you're using substitution until you get to the variable that was in the equation. You have to have that variable solved for. So solving for u is not sufficient. You have to keep going and get x. That brings us to the end of the practice test. If you have any questions, let me know. If I made any mistakes, please let me know. I hope this helps you in preparation for the exam.